Hi friends, so in this session we are going to solve one numerical on 2 degree of freedom system. Now if we see for the 2 degree of freedom system, the steps that we are going to use to solve the numerical are similar to the derivations of 2 degree of freedom system. Means the numerical is nothing but the derivation. Finally, at the last step, we are going to put the values of the masses and spring stiffness. We will get the answer. Otherwise, this problem is nothing but the derivation of 2 degree of freedom system. Now, to solve this, the steps that we are going to use are, the first we will have to determine differential equation of the system. Then, put the solution into the differential equation, and most important thing, determine x1 by x2, that is the amplitude of 1 divided by amplitude of 2. If the masses are 2, then we are going to get 2x1 by x2 ratio, and finally equate these two ratios so that we will get the solution. Okay, so this is the simple one where just remember that determine differential equation, put the solution, determine x1 x2, we will get the answer. Okay, now to solve this, I am going to start with I'll require the FBD of the given system. So here I'll draw FBD of the given system. Now to draw the FBD, just see how many masses are given into the system. Just check, this is the mass 1 and this is the mass 2, means they have given 2 masses. So I'll show you the 2 masses. This is the mass 1 and this is the mass 2. Okay, so they have given the 2 masses, so I have taken the 2 masses. Now show the displacement of each mass. See here, the displacement of mass 1 is x1 and it is in the right side. So I'll show this displacement is x1 and it is in the right side, and for mass 2 just check, it is also in the right side and this displacement is x2. So for mass 1 displacement is x1, for mass 2 displacement is x2. Now we will have to show the forces acting on these masses. Okay, as we are drawing the FBD, free body diagram, so we will have to show the forces acting on each mass. Now first show the inertia force. We normally show inertia force in the opposite direction to displacement. So here you just see the displacement in right direction, so show inertia force in left direction, and inertia force is nothing but F is equal to ma, and mm is mx double dot. This is the inertia force, but we are writing for mass 1, so this mass will be m1 and its displacement is x1. So the inertia force for mass 1 is m1 x1 double dot, which is in opposite direction to the displacement x1. Similarly, we can write for mass 2. Okay, so I'll show here opposite to displacement, and inertia force will be m2 x2 double dot, because the mass is m2 and displacement is x2. So this is the inertia force that I have shown. Now here we'll have to show the spring force. Now the spring force normally acts in the opposite direction to displacement. So consider this spring K1. See, this end is fixed. So as this end is fixed, so this K1 will elongate in the direction of displacement. So it will elongate in right side. So the force of spring will be on left side. Okay, so how to show this force? It will be opposite to displacement. So displacement in the right side, so the force will be on the left side. So this force is, spring force is nothing but K into X, but the spring stiffness they have given is K1 and its displacement is X1. So the spring force is K1 X1. Now we will have to show the spring force for K2. Now here I will make one star and remember this thing, how to determine the displacement for this middle spring. Now imagine this is the spring, your spring K2, and its length is 100. Its length is 100. Now consider that x2 is greater than x1. You can consider x1 greater than x2 also. I am going to consider x2 is greater than x1. So on this spring at this end the displacement is x2 and here the displacement is x1. Okay, so imagine this displacement is 20. Imagine this displacement is 20. So x2 is equal to 20. So after this elongation the total length of spring will become 120. And now imagine the left end is elongated and I will consider this displacement as 10. So after x2 the total length is 120 and after x1 the total length of this spring will become 110. So ultimately we can say that this spring is elongated. So if I consider this spring, means this spring is elongated. Now elongation of spring means both the ends will move in opposite direction. So this will be the displacement during the elongation. Now as the left end moved towards left, so here the force acting will be opposite. So it will be towards right. And if you see this end, as this end is moved towards right, so here the force will be towards left. Okay. So for x2 greater than x1 the middle spring will be elongated, so the right end will move towards right, the left end will move towards left and the forces will be opposite to displacement of spring. So on the left end I have shown the right force and on the right side I have shown the left force. See here, this is the displacement and the forces will be opposite direction. So here I have shown the displacement. Okay, and keep remember for the spring which is having the two masses attached on both the sides. Okay, now what will be the spring force here? What will be the spring force? The stiffness is K2 and the displacement of this spring is, here you can see x2 minus x1. So the total length is 110. So x2 minus x1 will be the elongation. So here I will write x2 minus x1. Okay, so the spring force will be K2 x2 minus x1. And as we have spring attached to m1 and m2, so I have shown the same amount of force here. Means this force and this force is same. Now just check for this mass m2. On the right side we don't have the spring, so there is no force on the right side of mass 2. Okay, so this is the most important step in the 2 degree of freedom, that we will have to draw the FBD. Okay, now keep remember the inertia force is opposite to displacement and spring force is opposite to displacement of spring. Okay, and from that I have shown the number of forces. Now after drawing the FBD we will have to use the differential equation. We will have to write the differential equation. So consider equilibrium condition. So I will write here equilibrium condition of system. So for equilibrium condition we can write the force on mass m1 is equal to 0 and force on mass m2 is equal to 0. First I will write for mass m1. So in the direction of inertia force I am going to consider the force positive. So the left side I am going to positive here. Okay, so write for mass m1. So m1 x1 double dot on left side, so it is positive, then plus k1 x1. K1 x1 is in the same direction, so it is positive. Now write for k2. Now write for k2. So k2 is in the right side but which is opposite to m1 x1 double dot. So I'll write this as negative, minus k2 x2 minus x1 is equal to 0. Okay, so this is the differential equation for mass 1. But I'm going to modify this differential equation. Here we have x1, here we have x1. So I'll take the x1 term common. So for that I'm going to multiply by this k2 inside the bracket. So this will become k2 x2 and minus minus plus k2 x1 is equal to 0. Now from this term and this term x1 is common, so we can write m1 x1 double dot plus I'll take x1 common, so in bracket it is k1 plus k2 minus k2 x2 is equal to 0. This is the equation number 1. Okay, so we got the differential equation from mass 1. Similarly, we can write differential equation for mass 2. So here I'll write for mass 2. So for second mass I'm going to write, so just see the forces m2 x2 double dot, which is on left side, m2 x2 double dot, then the spring force on the same side plus k2 x2 minus x1, and there is no force on the right side, so this must be equal to 0. Now multiply by k2 into the bracket, so m2 x2 double dot plus k2 x2 minus k2 x1 is equal to 0. So multiply by this k2 into this bracket, so we'll get this equation. Okay, so I'll write this equation as equation number 2. So we have the equation 1 and equation 2. Now in this equation, just see, there is x1, there is x2, there is x1 double dot and x2 double dot. So we can write the solution of this equation. So solution of equation 1 and 2. See, these two are the differential equations of vibration, and the vibration is with SHM. So we can give the solution x1 as x1 sine omega t, and this capital X1 is nothing but amplitude. Similarly, we can write x2 is equal to x2 sine omega t. So this is the first solution, this is the second solution. As we have two masses, so the degree of freedom is 2, means the displacements are 2. So if we have two displacements, then we have two solutions, x1 and x2. Now, so we know x1, x2 now, which is the solution, but in this equation we require the x1 and x2 double dot, that is the second differentiation of this displacement. So I am going to differentiate this x1. So differentiate this x1. So this x1 dot will be, x1 is amplitude which is constant, differentiation of sine is cos, and differentiation of omega t is omega. So x1 dot will be x1 omega cos omega t. Similarly, we can do for x2, but this is the first differentiation of x1, and here we will require the second differentiation. So I'll again differentiate this equation. So x1 double dot will be equal to, x1 is constant, omega is constant, differentiation of cos, it is minus sine omega t, and differentiation of omega t is omega. So this omega into omega, this will become omega square. So the x1 double dot is minus x1 omega square sine omega t. Similarly, we'll repeat for x2. So differentiate this x2 with respect to time. So x2 dot will be x2 cos omega t, and differentiation of omega t is omega. Now again differentiate. So x2 double dot will be minus x2 omega square sine omega t. Differentiation of cos is minus sine, and omega t is one more omega, so it becomes omega square. Similarly, I have written from this first one. Now put all these values into equation 1 and equation 2. Put all these values is in equation 1 and 2. So put in equation 1 and 2. So first I'll put in equation 1. So here I have written in 1. So I am putting this one in equation 1. So just see this equation. This equation is, first I will write the equation m1 x1 double dot plus x1 k1 plus k2 minus k2 x2 is equal to 0. So this is the equation 1. Now put the value of x1 double dot. So put this value x1 double dot here. So m1 will remain as it is, as this is having minus, so minus x1 omega square sine omega t plus, write x1 is nothing but x1 sine omega t into bracket k1 plus k2. So I have put here value of x1, then minus k2, put the value of x2 sine omega t is equal to 0. Now here this capital X1 is nothing but the amplitude and small x1 is the displacement and small x1 double dot is acceleration. Okay, now we'll simplify this one. See, here we have sine omega t, here we have sine omega t. So take sine omega t common. So in bracket it is minus m1 x1 omega square plus x1 k1 plus k2 minus k2 x2 is equal to 0. I have taken sine omega t common. Now transfer this sine omega t on this side. So this will become 0 divided by sine omega t means it will be 0. Okay, so it will be 0. Now I'll rewrite this equation. So before rewriting, I'll multiply x1 inside. So this equation will become minus m1 x1 omega square, or instead of that what we can do, I'll do some correction here. Instead of writing the equation, rewriting the equation again, here we have x1, here we have x1, so take x1 common. So when I take this x1 common, so in the bracket it will be remained minus m1 omega square plus here we have k1 plus k2, okay, and minus k2 x2. See, this sign we have transferred on that side, so that sign is cancelled. Now transfer this minus term on the right side, so it will become k2 x2. Okay, so right side becomes k2 x2 and here on the left side it is x1 minus m1 omega square plus k1 plus k2. Okay, now transfer this total bracket on right side. So when I transfer to right side, so it will go to the denominator. So it is m1 omega square plus k1 plus k2. Okay, so this is the denominator. Now from the numerator transfer x2 on the left side. So here will remain with k2 and this side will become x1 as it is and transfer this x2 here. So we will get the ratio of x1 by x2. So I will mark this equation as 3. Equation as 3. See, we got this equation because just I will quickly revise. See, we have the differential equation here 1, and in that differential equation we have entered the value of x1 and x1 double dot, that is the solution, and after putting the solution we got x1 by x2, but that we have put into the equation number 1. So here we have written put in equation 1 and 2. Now we have solved with the equation 1. Now we will solve with the equation 2. So for that first I will write the equation 2. So here I will write put into. Now I am going to put into equation 2. So first write the equation 2. See, here we have equation 2 and that equation is m2 x2 double dot plus k2 x2 minus k2 x1 is equal to 0. Now put the value of x1, x2 and x2 double dot. See, here we have in the solution x1, x2 and x2 double dot. So I will write m2. What is the value of x2 double dot? Minus x2 omega square sine omega t. See here, minus x2 omega square sine omega t. Now put the value of x2 here plus k2. x2 value is x2 sine omega t minus k2. What is the value of x1? x1 sine omega t equal to 0. Okay, now take sine omega t common from this equation. So take sine omega t common. So sine omega t I'll take common. So in bracket it will remain m2 x2 omega square plus k2 x2 minus k2 x1, and it will be equal to 0. Now transfer this sine omega t on the right side. So it will be 0 divided by sine, and 0 divided by sine is 0. So this side will become 0. Now in this side take x2 common from first two terms. So take x2 common from first two terms. So in bracket m2 omega square plus k2. Okay, from first two terms take x2 common, and this x1 term will remain as it is, that is k2 x1. Now transfer this k2 x1 on the right side. So when I am transferred, so it will become plus, and here we have x2 minus m2 omega square plus k2. Okay, now what will require from this equation? Will require the ratio of x1 by x2. So x1, transfer this x2 on this side. So x1 by x2. So this side will remain minus m2 omega square plus k2. Now transfer this k2 on this side. So it will be in the denominator. Okay. So this is the x1 by x2, which is the equation number 4. So I'll just quickly revise. See, first we have drawn the FBD. From the FBD, for the equilibrium condition, we have written the two differential equations. The solution of differential equation is x is equal to x1 sin omega t, x2 is equal to x2 sin omega t. We put all these values into these differential equations, and we finally got x1 by x2 ratio. Now from 3 and 4, what we can write? From equation 3 and 4, what we can write? We can write this 3 and 4 is same. So from 3 and 4 I can write, first write for 3, k2 divided by minus m1 omega square plus k1 plus k2 is equal to, from 4 what I can write, minus m2 omega square plus k2 divided by k2. Now we will have to solve this equation. See, till this point I have not entered any value which is given in the numerical. Means if I solve this equation, this will be my derivation, and if I put the values, then this will be my solution for numerical. So I am solving the numerical, so I am going to put the values. Now see, the mass m1 is 200, mass m1 200, m2 is 50, k1 1 into 10 raised to 5, k2 2 into 10 raised to 4. So I'll put m1 m2 250, m1 m2 250. So here I am going to write m1 is 200, m2 is 50. Okay, so m1 m2 I have written. Now just go above. So m1 m2 I have written. Now write k1 k2, k1 10 raised to 5, k2 2 into 10 raised to 4. Okay, k1 10 raised to 5. So this will omega square, k1 1 into 10 raised to 5 means 10 raised to 5 plus k2 2 into 10 raised to 4. So 2 into 10 raised to 4. Now here m2 omega square plus k2 2 into 10 raised to 4 divided by k2 2 into 10 raised to 4. Now just solve this equation so that you will get the solution. Now to solve this equation, what I am going to do, transfer this denominator on right side, transfer this denominator on the left side. So 2 into 10 raised to 4 into 2 into 10 raised to 4 means I have transferred this side here. Now transfer this one on this side. So 50 omega square plus 2 into 10 raised to 4. This is the first term, will be multiplied by this term. So this term will become minus 200 omega square plus 10 raised to 5 plus 2 into 10 raised to 4. Okay, now we'll have to solve. Now for solving this equation, this will become 2 into 2, 4 into 10 raised to 8 equal to this side minus 50 omega square plus 2 into 10 raised to 4 into minus 200 minus 200 omega square plus, on the calci solve this one, 2 into 10 raised to 4 plus 10 raised to 5, so this will become 1.2 into 10 raised to 5. Okay, now multiply by this bracket into this bracket. So start with this first term, multiply by this first term to this first term, so this will become minus 50 into minus 200. So minus 50 into minus 200, this will become 10,000. Okay, so minus 50 into minus 200, omega square into omega square, so it is omega raised to 4. Now plus multiply to the second term, minus 50 omega square into 1.2 into 10 raised to 5. So we have multiplied by first term, now multiply by the second term. So minus 200 omega square into 2 into 10 raised to 4. Now multiply to the second term, plus 2 into 10 raised to 4 into 1.2 into 10 raised to 5. Okay, so we have multiplied by first term with the all and second term with the all. So this is the multiplication. Now we'll have to solve. Now for solving, this is the 10,000 omega raised to 4, minus minus becomes plus, minus multiply by this one, 50 into 1.2 into 10 raised to 5, it will become 10, just wait, 50 omega square 1.2 10 raised to 5, so it will become 10 into 10 raised to 6 into omega square. Okay, then plus multiply by these two terms, these two terms are constant, so if I multiply, so it will become 2 into 10 raised to 9. See, for the solving, I have solved this one and I have taken omega square common, so we got this term. So 4 into 10 raised to 8. Okay, now to solve this equation, transfer this 4 into 10 raised to 8 on this side. So 0 equal to 10,000 omega raised to 4 minus 10 raised to 7 omega square plus 2 into 10 raised to 9 minus 4 into 10 raised to 8. Now solve this one, solve this total term. So 0 equal to 10,000 omega raised to 4 minus 10 raised to 7 omega square. After solving this, this will become 2 into 10 raised to 9. Okay, 2 into 10 raised to 9. Yes, that is 2 into 10 raised to 9. Now sorry, actually in the calculation I have made one mistake. When I transfer this term here, then this term will become 0 on this side. So this is the 0. So transfer this side here. So ultimately we will get 2 into 10 raised to 9. So there is no need to write this term. So I'll make this small change. Okay, so that bracket is 2 into 10 raised to 9 after transferring that value, particular value. Okay, now to solve this, put omega square is equal to a. So this equation will become quadratic equation. So 0 equal to 10,000 a square minus 10 raised to 7 a plus 2 into 10 raised to 9. So this is the quadratic equation. Solving quadratic equation. So just solve this quadratic equation. How to solve this quadratic equation? The solution A will be equal to minus b plus minus root b square minus 4ac divided by 2a. Now put the values. Minus b means it will become 10 raised to 7 plus minus root b square means 10 raised to 7 raised to 2 minus 4 into the value of a is 10,000 into c is 2 into 10 raised to 9 divided by 2 into a is 10,000. If I solve, I will get the two solutions. If I put plus, then I will get one solution. If I put minus, I will get second solution. So a means omega square will be equal to, by putting plus we will get 1, by putting minus I will get another one. So we will get the two solutions for this omega square. Okay, and solving this one, just wait, I'll solve. So the first answer is 723.07 and the second answer is, wait, sorry, second answer is, wait. It is 276.22. So these are the two answers after solving this quadratic equation. But we want the natural frequency. So take the root. So omega n1 will be and omega n2 will be. Omega n1, take the root of the first value. So the root of first value is it is 26.89. 26.89 radian per second. So this is the first answer, and the second answer is, take the root of 276.22, it is 16.62. So these are the two natural frequencies of the given problem statement. Okay, so actually this problem is lengthy, but how to remember this problem? See, first draw FBD, then write differential equation, then put the solution into differential equation. We will get x1 by x2 ratio 2 times. Equate this ratio, you will get the answer. Okay, but for that we will have to do some calculations. Okay, so we will have to perform some calculations. Okay, thank you.